Okay, so for the first three problems, it's all about rectangles. Just to review some aspects of rectangles, and we know it's a rectangle because it says in the problem it's a rectangle, so we know it follows certain rules. So for a rectangle, opposite sides are equal, so this side is equal to this side, and vice versa, opposite sides are equal. And then also with the diagonals bisect each other, and they are the same length. So that means that this is the same length as this over here, and then since these diagonals are the same length, this is the same length as this over here, and that can help us with the problem. So for the first one, it just shows opposite sides here and says it's a rectangle, so this is the same length as this, and we can set them equal to solve for x, and I saw a lot of you had this set up, which is awesome. If you got x equals 8, you did it correctly. You're awesome. If you didn't, I'll quickly go through the steps on how to solve. You want to put all the x's on one side, and then all the constants on the other side, and you get x equals 8. Okay, and then for this one right here, again, the diagonals bisect each other, so that means that this is the same length as this, and we can set these equal to solve for x. If you got x equals 20, you got it correct. Good job. If you didn't, here is how you get the correct answer. You want to put this negative 4 over here, so you add 4 to both sides. 40 equals 2x, divide by 2, and x equals 20. Okay, and then for this one, it was a little bit harder to tell what was going on, but they're talking about the angle measures of the rectangle. So as you know, for rectangle, all the corners are 90-degree angles, so you can use that to help us. Also, because these diagonals are congruent and they bisect each other, you have isosceles triangles here. So this angle right here is the same as this, and then these are actually congruent triangles, like top and bottom are congruent triangles. So if you have this angle, you also have this angle. That's one way of thinking of it. Also, parallel lines and a transversal alternate interior angles are equal. But either way, this little angle is equal to this one. You have to decide what you're going to solve first. As much as I know these two angles are equal, this has an x and a y, and I can't solve for both at the same time. So I'm going to solve for x first. And these two angles add up to 90 degrees. So I can say that 5x plus 8 plus 3x plus 2 equals 90 to solve for x. So 5x plus 3x is 8x. 8 plus 2 is 10. Subtract 10 from both sides. Then divide by 8. And x equals 10. So that is one of the variables. And now I need to solve for y. So this angle and this angle are equal, so I'm going to put 3x plus 2 equals 6y plus 2. And now that I know that x equals 10, I can plug that in and just solve for y. For the next one, number 2, says the coordinates of the vertices of a parallelogram are here. What type of parallelogram is ABCD? So the type of parallelogram it could be a square, it could be a rectangle, or it could be a rhombus, or it could be just a parallelogram. as possible, but I think it wants more specific. So over here, I have graph paper. So when you do the benchmark assessment, you'll have a piece of graph paper. You'll actually have to draw the graph out to figure this out. Okay, so I just made a coordinate plane. And then I'm going to use these coordinates right here and put them on the graph. -3, 2, A. I'm making my point small on purpose because it'll make my image more accurate. Then once you have the points, connect the dots. You can use your ID too to get a straight line. Okay, now that I have it drawn, deciding between these, it's not a square. Rhombus, all the sides would be the same length, and I can see that's not the case. It's probably a rectangle. On the answer key for this, it talks about a lot more specifics, so it might have more specifics in the problem. So let me just go through like what could be asked or how it could be asked. So here we've already determined out of those 3 parallelograms it's a rectangle, but what actually makes it a rectangle? So something that makes it a rectangle is it has 4 90-degree angles. Using this, how do we prove that those are 90-degree angles? Well, we could actually use the slope here. So the slope from A to B would be down 3 over 1. So the slope here is -3 over 1, or just -3. And then over here, down 3 over 1, again, slope is -3, which makes sense because it's parallelogram, so these lines should be parallel. And then the slope of this from A to D up 2 over 6. So 2 6 or 1/3 is the slope here. And then for this side, again, up 2 over 6, 2 6 or 1/3 as the slope. And so what that means is these slopes are negative reciprocals of each other. Like the slope over here is -3 over 1, and then this slope is 1/3. And that means that these lines are perpendicular because this happens with the slope, because you have negative reciprocals. And since they're perpendicular, you have the 90-degree angles everywhere. The other way you could prove this is a rectangle or parallelogram is like opposite sides are equal. So you could find the length of the opposite sides and then prove that the opposite sides are equal, proving it's a parallelogram or rectangle, whatever you're trying to prove. You could also prove that the diagonals are equal as well by finding the distance between 2 points if needed. I know that's higher level. Some of you are ready for that, some of you are not. So you can prove this is a rectangle by proving the diagonals are equal or that they bisect each other by finding distance. A lot of work, but I don't expect them to have you do all that work, but they might have it as like part of the problem, like the answer choices. Okay, so that's us all for that. I'm just gonna have you like